Hey again, 6 hours later, still the crowd is there. Hopefully you're still awake. You heard a lot of sessions already with good stuff. Um, so hopefully I can keep you awake. Maybe you want to scratch a little bit after the whole day of good stuff. What do I want to cover today? I think I will get the wrong slides here. Let's see. Um, Maybe I get some slides, but I keep talking. So I started this morning talking about what's cloud native and want to focus now deeper on the security part. And if you look at cloud native environments, you can apply security on three pillars that we see. I closed my session with this. So you have a pillar that is called, or you have the development part where you create your application. You have the infrastructure part where you create your cluster on-prem. We have learned a lot about how this is working in Kubernetes. If you do it, if you're doing this on your own, you've heard sessions from Google where they give you some infrastructure which is kind of swipe with a credit card, but you can do easily mistakes and from a security perspective, and you should take care of this. And last but not least, you have this part, the runtime part, where you need to apply security like you did in the traditional world. So these are these three pillars I will talk about today. I will reiterate this several times because this is the picture that helps you to understand how to handle this. But first of all, let's take a little bit more introduction to this, why we should take care of it. And of course, you're all here because cloud native or DevOps, DevSecOps is a topic. Yeah? Otherwise, this conference would not exist. And what we found in several analytics is that already almost every company has some kind of cloud native installation in place. It is maybe not their main topic at the moment, but there are footholds already in place, and they run production. And if you run IT in production, either for your office or for your main business, you need to take care of it from a security perspective. This is what we learned in the last 20, 30 years about IT. If you put IT somewhere, someone will attack it and may steal something or impact your production. And what the other says is by year 2025, 95% of all new projects that are initiated are cloud native. So run on containers, run on cloud platforms like Kubernetes, run in a philosophy of the DevOps, and therefore it is also important to understand that some security may help, because traditional tools won't really work in this environment, especially first of all on the runtime side, where we have some tools that do runtime protection. They don't understand the container context, and if we audit cloud infrastructures, either a Kubernetes or a Google, Amazon, or whatever cloud, this is simply some new technology from this perspective. You need tools that can audit, understand this infrastructure, and give you hints about that, and moving to the shift left, doing more security when your application gets built helps you to don't spend so much time on the other topics. And what we also found, as I said, I work for Aqua. Aqua is a cloud native security company, and for a good security company, it is a good best practice to have a threat research team. Our team Nautilus, we publish blog articles about general threats regularly. We publish a yearly report about cloud native attacks. So in opposite to other threat reports that you may get on this also on your annual basis. We focus on cloud native, and the cloud native gives sometimes different patterns. Maybe the pattern that within 20 minutes, if you spin up a workload that it get attacked within 20 minutes, it's not a pattern that is really specific to cloud native, but it also applies to cloud native. And we found out that in the past, many people said, hey, no, we don't publish Windows servers into the internet. It is Linux and so on and so forth. We can't get, or we won't get attacked, and we are not hit by successfully because everyone is focusing on the easier part. But this is not true anymore. We all have learned about Log4j, but there are tons of other attacks that applies to the container world, not maybe to the container technology, but to the applications that are running there. So you are, if you run cloud native on Linux systems, you're now in the focus of attackers. Attackers found that they can get a stake out of it. And the simplest attack that we see is that they simply try to drop a crypto miner or something like to steal you some CPU cycles and get some money out of it. It doesn't hurt a lot. It is only money, right? But there are other threats. Sorry, this is maybe a little bit small from the font size. I want to give you a quick overview. You have heard today a lot of DevOps and different differentiators. I would like to give you again an overview, especially on the security side. Yeah? So in the traditional environments, you have these discrete releases, and maybe you run something, never change a running system. So if you have a stable release, you have not touched the server until something made you to change it. But in the cloud native world, you have the CI/CD jobs, you have sprints and so on. You release continuously. So continuously something is changing. So if you, for example, do learning or web application firewall that don't understand what you have deployed and what is new, you get false alerts and so on and so forth. So you need something that adopts your continuous change. This is the same with the workload itself. In the former times, we spun up a server, put it into our CMDB and so on and so forth, like ITIL made us to do. But in the container world, you will auto-scale. A container pops up here, get shut down overnight, or if it is not required, pops up there in another environment or on another server if required. So IP addresses are nothing anymore, right? So, and this is the same for the containers itself. Yeah? The hosts, you will scale the hosts and you will scale the containers. Yeah? And with this, IP address, as I said, IP addresses are not an identity anymore, which you may had in the past where you wrote your firewall rules based on IP addresses. So now you need something new as an identity, an application or whatever to segment your network that is running in the cloud. And the cloud is, for me, I don't care if the cloud is in your data center or at a hyperscaler, yeah? A Kubernetes stack, a Docker stack. It is very dynamic, and you run several applications on one hardware with kind of one IP address or whatever. But you want to separate different applications for security reasons. And then on the application side itself, you build up, if you build up an application, first of all, and a container is in most cases half an operating system that you carry with you, right? There are thousands of packages that are in the container that you not really need, but may have a security hole or something in it. So you need to take care of the base image. And of course, your application itself. You don't, as a developer, you don't start and write an SSL stack to do, or a TLS stack to do encryption. you use a common library for that. And this is absolutely the best practice. And you do it for 1,000 other things. You pull in third-party components, in most cases open source, but maybe also third-party tools. Yeah? And this gives another threat, because we saw that, of course, simply the amount of tools that you bring in from an operating system perspective, which is in the container, and from your application, there are hundreds or thousands of parts that could have a vulnerability. So it is first of all a simple management maintenance problem. But as you change these things more often and bring in new versions, as we started here in the CI/CD pipeline, you may pull in wrong packages, packages with new vulnerabilities, and so on and so forth. Or you may forget to update a dependency, and then you're vulnerable. So you need to take care of these things, and this is simply an administrative overhead that you need to be aware of. We try to help you to manage this, right? Yeah, this is also covering the reuse of public images and libraries. It is the same pattern. Yeah, you have a software supply chain risk that coming with it. You need to trust the third party that things are secure. And we saw this that for political reasons, someone inject malicious code, or it is simply that this was last week in the press that thousands of Node.js and Python packages were simply hijacked or feeded in for months, and with a simple useful function, and then they flipped into a malicious behavior. And if you now pull in the code, you get this in your application unaware, right? And last but not least, even if you start with a strategy, hey, I'm on-prem for whatever reason, yeah. I have many customers that started with this statement, and we never go into a public cloud. Or I've found customers that say, yeah, we are a Microsoft shop, we go for Azure, and that's it. Our cloud will run in Azure. If I meet the customers half a year or a year later, they say, yeah, but there was one project, we need X for this, and then you have another cloud. And you don't want to re-event then all of the security requirements and things that you do in this part. So multi-cloud capabilities is something that you keep in mind. And therefore, this is now again the three pillars that I already mentioned in the beginning. With a huge headline, and this is Cloud Native Application Protection Platform, also called CNAP short. This is not something that, an acronym that, or a name that I've invented. This was invented by Gartner. But Gartner said that you need something that covers your cloud and do the security there. And if you read it from right to left, it helps a little bit. It's a platform, so something that is generally working, that applies protection, yeah, to your application running in a cloud-native environment. And to do this, you need to find your risk, regardless where they are. If they're coming from the supply chain, from the software you pull in, or if they're coming from the normal attacks that attacks your application, or from a vector that you do a misconfiguration in your infrastructure, yeah? And you need to find them and to reduce them. And to help to reduce them is to catch them up as early as possible, so that you can give your developer or your DevOps guy a hint as early as possible. Hey, if you bring this into production, you will bring this risk into production. Please reduce it, or accept it and manage it, and get maybe an approval process that everyone is aware that you carry a risk with you. And then protection. Protection is very, very important. Especially from the supply chain attack. that you can write rules that nobody can bring in certain risks or certain vulnerabilities. This is stopping. This helps you to avoid or stop things as early as possible, which makes it cheap from one perspective. Catching problems as early as possible makes the error correction very cheap, and it makes it reliable because you have no risk exposure at one point in time. And at the end, you need something that stops the attacks and not your business. So you should have bring something in your production that is not eating up your additional CPU resources, but can block attacks as they occur. Yeah? And maybe you need this from a vendor that has long year experience and not doing the first steps now with it. So to wrap this up, you need to stop cloud native attacks, and we help you. So Aqua is doing this on all these with all these aspects. And here's another build with these 3 pillars. So if you're running a CI/CD pipeline, if you have a code repository, start scanning there. And you can start scanning with our open source tools, Trivi. And maybe many of you have already heard about this. Aqua do a lot of open source tools. And they are also part of our commercial offering. And they run underneath this commercial offering in the same manner as the open source tools run. What we bring with our commercial offering is an enterprise management policy set and so on and so forth, reporting, role-based access control and so on and so forth. But the core technology is in many cases on the Aqua side open source, so you can start with our things kind of for free. You need to train yourself on it. So in most cases, if you scan your code, we use Trivi, and we find there are not only vulnerabilities, we are able to find their malware, misconfigurations, we can find secrets. So if someone put in an API key, an SSH key or whatever, this should not be part of your software, it should be managed out of band. We have heard this, for example, for HashiCorp, how to handle this with a vault. But if sometimes it happens for testing or whatever, a developer puts something in, and this needs to be avoided, right? We can detect these things. We can also spin up the things that you have created. We can spin up your container and do a dynamic analysis, right? So because some malware only is detectable if it is running, yeah? And we can detect malicious behavior like communicating to the outside world, doing certain things, launching code from memory or whatever. And then we can make you aware, hey, the thing that you have created here or pulled in from external, it is often that external libraries or base images contain these vulnerabilities and not your internal developer did the shit. That this is something that you don't want to bring into production. And we have heard here from banks, if they run containers and they have contact or the container can access customer data, you run in big problems from certain perspectives, the customer data and so on and so forth. The second step is harden your infrastructure. As I said, it is easy now to ramp up infrastructure because the infrastructure is not bringing in a server into a data center. If you have created your stack in the data center, or if you rent this from a hyperscaler, it is only configuration to spin up containers, to spin up Lambda functions or functions, a database. You can do it by software, and this lowers the barrier to run IT services. And we see this especially in big companies, as small teams start to ramp up their own IT services because their internal IT takes too long to deliver this stuff. And then they do misconfiguration because they are not trained how to do it the right way. So scanning your infrastructure and finding misconfigurations is critical, yeah? Because the things are also so fast moving, and even a very experienced ops guy can do simply the wrong click in a UI somewhere, or miss a command line parameter or something in a YAML file, and then the application will behave different. It's, for example, exposed to the internet, or he did some testing and uncommented something out of a configuration and makes it therefore vulnerable. So it's important to harden your infrastructure, because it is your containers run later on this infrastructure, and containers are user space processes. So if someone gets a container and they run on a vulnerable infrastructure, the attacker can take over your complete data center, which is kind of virtual and running in a Kubernetes or whatever, right? So we help you here with certain tools. From one point, we use audit accounts from your cloud vendors to check how your cloud is configured. And again, here it's very helpful. We don't care if it is Google, if it is Amazon, or whomever. We do for every account the same, and make you aware of misconfiguration, and we can auto-remediate, for example, put in ACLs that services can't be exposed to the internet without an exception or something like. And we audit and also your Kubernetes infrastructure, that you can't do misconfigurations, and we can enforce there that you, for example, can't configure an over permission, you can't deploy a container with root permissions, and so on and so forth. So hardening the infrastructure helps you to keep it up and running. And here is also a set of open source tools that we provide, where you can start with this. If you want to, for example, bring this all together, to understand that an image with vulnerability should not be started in your Kubernetes, then our enterprise platform that sits underneath helps you to write the right policies. But you can start with our open source tools. And last but not least, you have the workload protection, where you can do a lot of things. First of all, understand what you're running. So give you a visibility which containers runs where, on what kind of worker nodes. So we assess your worker nodes, especially if you create your own cloud, you need to maintain the worker node. And as I said, container is a user space process on a worker node, so the worker node need to be secure. So we do a vulnerability assessment, not only for your containers that we can do here on the shift left side, we also detect vulnerabilities at runtime. And then we do normal malware protection. So this is what we have agreed on, that is required on each and every worker node, each and every computer nowadays. We can do it also in your cloud native environment, on the worker node and in each container. So if someone brings in malware, and malware could also be a crypto Trojan or something like, we can detect known threats. The next thing is to prevent unknown threats, and therefore we can apply container hardening. Containers are purpose-built, right? The idea is not to have a full-blown application that do many things in one container. One container do one task. And with this, you can easily say, hey, I don't allow to start many things in the container. And our simple rule set is here. You are not only allowed to start something that was originally in the image, what your developers put in to the image. So nobody can bring in code from the outside. And this helps a lot, because nobody patches a container, nobody brings in new binaries. So we saw this with Log4j. We saw that someone was able to use a vulnerability in Log4j because it was vulnerable, but then the attacker need to bring in something to run this attack. And the attacker was not able to launch his own crypto Trojan because it was not part of the image. He wanted to download this from external, and we were preventing this. And then the attack can't be launched. Beside that, we do malicious behavior detection. If someone lets kernel modules do certain evil things on the endpoint to make you aware of new attacks that not follow known pattern, that you can get a risk understanding of your workloads in production. So I will flip quickly through some countermeasures that we do on these pillars. So it is vulnerability and risk scanning. So and here we have an overview, but our recommendation is do all the vulnerability and risk scanning from a code perspective side in the tool set that the developers use, in the Jenkins, in the Git, in the GitLab Bitbucket, where we can integrate into pull requests and give the developer doesn't need to leave its known tool set. We will provide comments into a pull request or in a Jenkins. We have a plugin where we deliver the vulnerability report into the tool the developer use by day to day. And many customers of us, developers has no Aqua login or whatever, or a management login. They can work with the results that they get in their tools to fix certain things. And also, the risk scanning and risk management is important to allow exceptions. For example, we have a simple rule that says a new vulnerability may not block your sprint for a certain time. So we can say a new vulnerability has a grace period of 15 days or whatever days until it will block the release. Because developers need to adopt your security, and if you bother them too much, then they will find a way around. This is how it works, right? And having the right, the ability to write policies gives you a better adoption on the shift left side. And as earlier you pick up the vulnerabilities, and as more stable code you ship, as less you have to do on the other steps. Risk-based insights is also important. Understand the priority of a threat, and therefore we can correlate the information from all these three pillars. So we can say, hey, here's something running exposed to the internet with a vulnerability on an infrastructure that has maybe over permissions on a certain resource in your environment. So please focus on these threats first, and then after that, maybe there's a threat on something running internal, not exposed to the internet with a lower severity or something like so. Because especially if you start, you get a long shit list by definition. I already covered the dynamic analysis where we find threats before threat that only occurs at runtime. So harden your infrastructure. Very quickly, it is assessing your environment, understand if you did configuration mistakes. We can do audits based on certain compliance standards like ISO 27001, PCI DSS, and so on and so forth, to help you to get an understanding of what your state is there. And of course, we help you to remediate these things. And not only on a cloud provider side, but also on the Kubernetes side, we paint your clusters with the namespaces and the risk on the certain resources you have, so that you can understand and mitigate the things. And of course, it is drill down. You can do a drill down here. It's interactive, clickable to find your risks. Compliance auditing, I've already covered, because I'm running a little bit out of time. I will speed up a little bit. Protecting your workloads. Of course, it is not only the containers, but also the workload, your worker nodes, your virtual machines, your serverless functions, and so on and so forth. You need to understand what you're running there, and if they do malicious things, either known malicious or unknown malicious, and then you need to the ability to write your custom rules for different applications, because you want to handle certain threats differently, and then reporting them back, collecting forensic information that helps you to understand if a threat happened, what happened, if you need to report this incident, or if you were able to defend this before something worse happened, for example, loss of customer data or something like that. As said, we have the drift prevention that hardens your container. We have another functionality that's called vShield that helps you, if you have a vulnerability on a running workload, to make this vulnerability not launchable. So we can block, for example, if your operating system or your container brought in a library that is not essential for your application, we can block the execution of this library, and then you can run this container until your development team has shipped a new container. So you don't need to run an escalation, and this helps you to give time at the developer to not run in pressure, do proper testing before you ship a new version without the vulnerability. So this is my quick view through cloud security, how Aqua understands this and how we can help you to tackle these things down. As you see here, our main alliances partner, it's not only the common cloud providers, but also, for example, Red Hat with OpenShift, but we have support for pure Kubernetes, or almost every Kubernetes flavor is supported. Docker itself it's supported. If you think about Docker, it is we can apply also security on Docker containers running on Fargate, where several solutions are not able to help you, and so on and so forth. So this was a quick intro into cloud security from my side.